Good morning, good afternoon. So I welcome everyone to the first webinar in the new year. So it's my pleasure to introduce this distinguished speaker, Dr. S.S. Mani Venkata. He's a president of Venkata Consulting Solution, and he provides the R&D support and services for electric power industry and training for future engineering power for personals. He was with the GE Power Alstom from 2011 to 2017 as a principal scientist, and he was a vice president with the KEMA Increments for 6 years during 2005 to 2010. And he was a founding dean and distinguished professor with Wallace J. H. Kotler School of Engineering at Clarkson University, Potsdam in New York during 2004 to 5, and in 2003 he was a Palmer Chair Professor of Electrical and Computer Engineering Department, Iowa State University, Ames, Iowa. From 1996 to 2002, he was a professor and chairman of the department at ISU. Before joining ISU, he was with the University of Washington, Seattle, where he taught since 1979. He still continues with his affiliation. And prior to joining UW, he taught at different universities, including West Virginia and University of Massachusetts Lowell for 8 years. And Dr. Venkata is a life fellow of IEEE. He served IEEE fellow committees for 6 years, and also he served as a Power and Energy Society Board Vice President during 2004 to 7, and he served PES at various levels for past 55 years. That's really a great honor. And in 2006, he received the Robert M. Jonovic Outstanding Leadership Service Award from ECE-DHA. He also received the IEEE PES Douglas M. Stutsky Distinguished Automation Award in 2015. In 2000, he received the Third Millennium Award from IEEE, and in 1996, he received the Outstanding Power Engineering Educator Award from IEEE Power and Energy Society. I welcome our honorable speaker, Dr. Mani Venkata, to take over.
Oh, thank you, Sanjeev, for that gracious introduction. And I'm delighted to present this webinar. I just want to make it clear that this is precisely what I presented in Delhi during the UI Assist program. So for those people who attended that, this will be a repetition. And I just want to have, how do I get a pointer to show things? Can you help me, Sanjeev?
I think, yeah, maybe I can give an access, but that is a little tricky. I can try. So maybe you can ask for access.
What do I do?
Yeah, just go back into the presentation mode.
Okay.
And on the left side.
Okay.
Of your, so go back into presentation mode.
Oh, actually, I'm sharing the presentation.
Okay, so that's fine. You can just go from one slide to the other. Okay.
Okay. Yeah. Sure.
I just want to make sure that this what I presented already in Delhi, but anyhow, I'd like to say that this is an unusual presentation in the sense it is both technical, but at the same time, it also talks about some non-technical issues. If you see the title, it is called Design Guide. I think I need to pause here and explain that according to IEEE Standards Association, the first step in getting any standards, first you have to apply for a program application request and to ask for a guide. The first step is guide, and then if you nurture it, the next process is go to the recommended practice. And once it is a recommended practice applied by or tried by many utilities, then it goes into standards. So this is a long process. It may take, to get a standard, it may take as many as 10 years. And if you see in the title, it's a microgrid protection, and which deep deployment of distributed energy resources of all types, with all the renewables coming and so on. Inverters, which have become very common, and we are still learning more about it. and other digital devices like smart devices and smart breakers and the smart reclosers and other things. So that's what this the whole topic about. Next slide. I would not endeavor to present every detail, but highlight it. And as Miroslav advised me that just stick to 30-minute presentation. This is an outline of the presentation. I will go through a quick preamble and history. And what I am showing as chapter names are nothing but the chapters in the Sandia report, which you will see a little later. So there are 14 chapters, and these are the titles of those chapters. Next slide. And so you can see that at the end of the chapter 14, you will have some conclusions which are very important, and we'll talk about it. Next slide. Okay, this is the starting point, and the impetus for this whole project came from the Department of Energy Office of Electricity, realizing the need for microgrid and associated problems. And microgrids help in not only improving the reliability, but more importantly, resiliency. And so with that in mind, the Power Systems Relaying Committee provided the needed support via several working groups, including C30 and C38, and agreeing to sponsor the program acceptance request, program approval request for initiating this P2030.12 working group for this work. It's important to realize the P2030 relates to the smart grid standards, and .12 is the current one on protection, but there are previous documents that already have been approved, like 11, 10, 9, 7, and 8, and so on. And the PAR was initiated in 2018, and the 2030-12 was approved by end of 2018. And we started functioning in January 2019, meeting once in 2 months, alternating between face-to-face and web conferences. The last count, I don't know, but the working group has more than 145 members who are taking really very active role. Next slide, please. Okay, the preamble and history is there are 14 chapters of the draft report that are available in the IEEE Standards Association iMeet Central. iMeet Central is a central depository for all the documents. And so this is a summary of the draft report. The full report is expected to be completed by December 2024. And so because we needed to take care of a lot of other things, the request has been approved up to end of 2024. Soon after that, it will be forwarded to the Standards Association for formal approval. We encourage the interested IEEE members to join and participate actively. I hope all the people in the call as well as in this project take an active role. It's a goal to develop a white paper on the importance of standards. I think something is blocking here, so maybe I need to, yeah. Standards and development. And so this is what the whole process is. Next slide, please. The scope and purpose, they're all clearly defined here. I'll let you go through this, and but the scope is guide covers the design and selection of protective devices and the coordination between them for various modes of operation. This include grid-connected, islanded modes and transition between them. The guide will also facilitate the deployment of protection systems, given the challenge of protecting equipment and assets in the different modes of operation of the microgrid, including grid-connected, islanded, or during transition. Okay, so the guide proposes more approaches: centralized and decentralized, passive and active, to detect and take proper actions to dependably and securely protect the microgrid and its protection. So dependability and security are very important concepts in protection, so that should not be neglected or not and should be taken into consideration. Next slide. Okay, this is the basis of the Sandia report. This microgrid protection, advancing the state of the art, and this is the site and where the advancing the state of the report appears. Next slide. And DOE definition of microgrid is perhaps well known, but I think this is a very important concept. We need to see that. What it says is a group of interconnected loads and DER within clearly defined electrical boundaries. This is a very important thing to keep in mind, that acts as a single controllable entity, and that can be either normally connected to a distribution grid or operated permanently isolated from a larger grid. Here again, you need to know that from the right side, the picture shown, that the purpose is to improve the reliability and resiliency. Next one. Next slide, please. Okay. There are chapter 5 in this report talks about different types and structures of microgrid, customer type of microgrid, community microgrids, and it also encompasses AC, DC, hybrid microgrids, and operational modes, grid connected, islanded, and transitions between them. And it's important to recognize this is a recurring theme appear throughout the report. Transitions from grid connected to islanding include unplanned islanding, planned islanding, reconnection, and black start. And this figure shows the types of microgrids and the sequences associated with the microgrids. And it's a very good slide to go through that. And please, when you get time, okay? Now, next slide. This encompasses the dispatch operating modes in a very comprehensive way, and it takes into consideration steady state, unplanned islanding, planned islanding, black start, reconnect, and steady state. So this is the core central issue of the microgrid modes of operation. Next slide, please. Grid connected mode of operation is pretty well known, and so I won't endeavor to go through this one, and please go through the important points here. And so that, except I want to tell you, these are interconnected and interoperable, and I will address this a little later to the local EPS. EPS is electric power system. We did quite a bit of discussions during past meetings, even to define EPS. So some of these things are given a lot of consideration in taking care of the issue. Thank you. Next one. Islanded mode of operation. It is, I can't get rid of this bottom. This okay. What's happening? Am I doing something wrong?
No,
So
you're
you don't
good.
see
I
it
think
on our screen.
yeah, we could see the.
Okay, now the important point here is the last one, 1547-2018 standard provides criteria and requirements for DER integration and interoperability for microgrids operation. And I need to let you know the 1547 is a normal standard, but 2018 is a recent revision. And I think that you should take this one in conjunction with P2030.12 when you consider it further. Next slide. Planned islanding is a very well-known process. Here, the only point I would point out is the DSO, the distribution system operator. This is a very well-known concept in Europe, and I think we are trying to get slowly used to the used to that concept. And so we hope in future we will take care of that one. Next slide, please. Unplanned islanding. This is the most difficult thing to concentrate, because when an islanding happens unexpectedly, so this poses a lot of challenges from a protection point of view. And so the important thing is sometimes you may have to do pre-planned actions such as load shedding and so on to get the frequency balance. And so transition to steady state islanded dispatch mode is something requires quite a bit of process listed here. Next slide, please. Transition from the grid connected to islanded operation and vice versa is a standard process, and all the details required for this are listed here. I want to tell you, anytime you don't get sleep, you can take time to go through these things and go through the details. And I want to make it clear, if you have any questions, please feel free to contact me at any time. Next slide, please. Reconnection to grid is something similar. We have been understanding in the past classically. So what all it means is you have to set and match the voltage, phase angle, and frequency. This is what we have also done in the past for synchronizing this the synchronous machines and other things. Next slide, please. This is an interesting, in this chapter of the Sandia report, microgrid protection system design configurations are all discussed. And on the right side, it shows what happens for a three-phase fault near a PV inverter. And you can see that what happens before and what happens later. And it's an interesting experimental result to study. But the core issue here is grounding design. You need to be aware of that one, that grounding plays a very important for protection, and that cannot be ignored. And that's what it is listed here. Next slide, please. The chapter 7 of the Sandia report discusses protection objectives and challenges, which are very common. And only thing is you have to realize that there is a bidirectional fault current flow that happens in this case in microgrids, and we have to be aware of it. On the right side, it shows for a single line to ground fault applied to your three-phase grid following inverter and grid forming inverter. These two are two important concepts that need to be, you need to keep in control. And in grid following, there will be no negative or zero sequence current, as you see on the top figure. But in grid forming inverter, you will have all three sequence current equal in magnitude, but you can see the transition that take place on the right side. And so this is very important to keep in mind. Next topic, next slide, please. Okay, in chapter 7 of this report, microgrid protection objectives are all discussed, especially for the inverter-based DERs. There are all these challenges come into effect, and also it talks about relay interoperability and cyber security, which are two very important concepts in keep in mind. And it also talks about impacts of control strategy on its protection. And then finally, ADMS functions. So here you can see how computer control and they come into picture in a very integrated way. Next slide, please. Okay, relay interoperability. What all this says is interoperability means how do you make, you take out one relay and insert another manufacturer relay. How can you make it agnostic to the process without losing the process? So that's what the whole interoperability issue talks about it. Next slide, please. Cybersecurity is a very important aspect, and you know that cybersecurity must be given a proper attention. And you can see on the right side how cybersecurity with respect to microgrid plays a role, along with all components involved shown around it one. And here again, I want to say that the reason in North Carolina, the incident that happened got quite a bit of attention, and that is related to the cybersecurity. And so that we need to keep that in mind. Next slide, please. Protection system structure. This shows what the structure could be, and it's in a decentralized system. We need to worry about line feeder protection, and also you have to be careful about POI, point of interconnection versus point of common coupling protection, how it plays a role, and point of common coupling deals with the manufacturer details, whereas point of interconnection, excuse me, deals with how it is interconnected to the system. And microgrid system protection and control is also discussed very much in detail in this report. Next one, please. Next slide, please. This one is a centralized system. The important point is to see that for both power line power connection as well as the communication as one-to-one correspondence, as you see here, and that's very important for the power microgrid protection. Next slide. The modes of operation of the protection system. This is the one where it describes a case study done by the Schweitzer Engineering Laboratories, and common protection done at the point of common coupling, and the challenges still remain. These are listed below here. Next slide, please. Protection system studies. In any type of system, either a classical or microgrid future thing, and we have to do several system studies to understand the process very well. So the first and foremost, you need to do the power flow study. Following that, you need to do the short circuit study, which we always do for a classical protection, but that needs to be done in this case too. And it talks about in the short circuit studies, what are the improved models required for the inverter based resources. Then following that, dynamic study is required, and the important thing is again to realize differences between dynamic studies of the bulk grid and microgrid from microgrid protection point of view. And finally, transient studies and electromagnetic transient studies and hardware in the loop simulation need to be done. In this case, I want to tell you that the best place you can learn more about hardware in the loop simulation is in the NREL facility, and they do a great job, and Murali Bagu can help in case you want to contact him. And this has to be done for all modes of operation, and that is an important thing. So it's a pretty involved process. We're all learning, but we cannot ignore them. Next slide. Microgrid control system coordination. Here it talks about controller functions and interactions and sectionalizing considerations under faults. So there is nothing in terms of new, but there are a lot of details you have to learn from. You can learn from this chapter. Next one. Next. Okay. Here, this chapter talks about ADMS, Advanced Distribution Management System, as well as Microgrid Energy Management System protection functions and coordination. And it talks through all the details of protection due to integration of microgrids and what are the requirements for coordination and your analysis in various event scenarios. So this is important to realize A lot of scenarios come and we have to encompass all of them and detailed discussions on all types of faults. Next slide. This is my favorite topic, micro PMUs. And as you know, micro PMUs are playing a very important role. PMUs are expensive, but thanks to the power standards firm, they developed this micro PMUs, and it plays a very important role in our topic. And one such application is the fault location on a distribution electric power system or microgrids with micro PMUs providing very accurate results. So you can see the benefit that comes from using micro PMUs. Next slide. Chapter 13 of the Sandia report talks about protection system communication structure. And here this chapter describes all types of communication systems and how do you communicate with the DER or microgrid, higher level of communication, interaction with protection system, and coordination with the protection system. So this is the chapter dealing with all communication aspects of the problem. Next slide. Chapter 14 is a very classical chapter. It talks about protection system design. It describes the testing methods and procedures, and it also talks about lab bench studies for classical testing, and also as well as hardware in the loop testing, and which I already alluded to in terms of NREL providing the needed support. Next one, please. Okay. In terms of conclusions and remarks, I just want to make sure or emphasize that microgrid protection is not like conventional transmission or distribution grid protection. It's an animal by itself. This paradigm shift needs creative and innovative thinking and may have to be treated as a radical process. I want to underscore this bullet and please keep that in mind. Microgrid protection, control, and automation need to be integrated as a comprehensive process. Control, communication, and automation, they go together, and that needs to be realized here. And this is an evolving and ongoing effort, and by no means it is complete. So what I discussed here is the status of current progress in this webinar. Next one. Next slide, please. Okay. Current status. What's happening to this report? I already said that the Standards Association is an operating unit that develops global standards in a broad range of industries, including power and energy. In fact, more than 80 standards are in the power industry area. And for this particular topic, we received totally 520 mandatory editorial comments. And we are going through this with a fine tooth comb, and we have to take care of this one. And we invited working group members to participate in comments resolution group. And you won't believe it, these meetings are going on in a very rapid manner. And in order to do that, we requested that PAR be extended to December 2024. And we already got that approval. And several working group meetings are planned to implement this process, excuse me. And actually, as we are speaking, we are going to have weekly meetings from next week, and we will be working very aggressively on this one until we complete this process, because in order for us to get the process completed, we need to finish all this mandatory comments resolution by end of this year, 2023. Next slide, please. So that's the end of my presentation. I'm not sure whether I did justice to this whole process, but my apologies to people who have heard this presentation in Delhi. But it looks like a lot of people participated today, and I do really appreciate it. And now I will open this floor for questions. And I took 34 minutes, but I'm glad I did. But I'm here to answer any questions from all the people who attended are attending this webinar.
Yeah, thank you, Dr. Mani, for interesting presentation. So I think I saw one question from Professor Anurag. Maybe I'll ask him to just unmute and ask the same.
Okay, what's the question?
Yeah, so that
Yeah.
was about your comment on North Carolina cybersecurity case instance. So can you tell a little bit more about that?
Repeat it again.
You know, in one of the cybersecurity slide, you talked about North Carolina event.
Oh, that's the one. Recently, somebody deliberately attacked the system, and it has gone to the level that the governor also had to interfere, and then they are doing some legal, investigations now. And that's what I just said this because sometimes people deliberately also attack that, and how do you take care of that one? And I think quite a bit of news has been released through the regular commercial channels. And I thought I'd let you know that because sometimes if deliberately the system is attacked, how do you take care of it? And that's not, there's no process known at this point. People are learning.
Yeah, so that was a physical
question.
attack, right? Not a cyber attack.
Well, it's not a cyber attack, but it's a physical attack, which I think affected the cyber security from my point of view.
Okay, yeah, thanks.
Thank you. Any other questions anyone would like to ask? They can unmute more. And yeah, there is one more
in the chat.
Yeah, I can see that. Thank you. So does this include the protection for DC islanded microgrid systems? What are the report you presented or the guideline? Does it include the protection for DC islanded microgrid systems?
Yes, it does.
Okay.
Yeah. Because there are a lot of DC microgrid coming, and we need to be aware of the islanding problems, and both AC and DC need to be integrated. I mean, so need to be considered. Excuse me.
Okay. Thank you. And then I have one question on the micro PMU. So you said like micro PMUs are emerging. So I would like to know what exactly the difference it brings into the industry when it compares to the high resolution measurements, what we already have it in the field, like power quality measurements or other types of measurement, which can also capture the same kind of phasor, voltage magnitude and the phasors. So what exactly the difference that comes out of the micro PMUs?
It's the accuracy. You know, the micro PMUs provided the much more needed accuracy than in the past we could do that. And so that's the additional benefit out of that one.
Okay, so in terms of the data wise, but we still get a good amount of data from the PQ meters by default. So right. The micro PMUs are still at a low rate compared to the PQ meters. So how are we going to justify the resolution wise? I mean, the accuracy still, it's the higher the amount of the resolution you have, like you can easily debug or maybe look through finely. I mean, this is just hard.
From my understanding, that micro PMUs provide better accuracy than the classical way of getting the, doing the process.
Okay. Yeah.
If I'm wrong, somebody can correct me. I will be very happy to listen to them. I think some handies have Yashodan Agal Gaonkar.
Yeah, go ahead. Yes.
I have a question for.
Can you speak up?
Hello, can you hear me, sir?
Yeah, now I can hear.
Yeah, so I have a question for Professor Mani. Of course, we agree with him that micro PMUs bring a better accuracy. What my question is that at the moment, is he seeing in practically micro PMU measurements are integrated in DMS and DERMS architecture? Or outage management architecture, because AMI is integrated. Are we seeing that integration, sir?
Yes, it is happening, but it is still has to not completely what you call included in the process. I think this is an evolving issue. Let me put it that way.
Okay. Okay.
Manny, if I may, this is Gary. Yeah, I agree with Manny. We're seeing a lot of our clients turning towards micro PMUs as a alternative, and they're all very confident that the cost recovery mechanisms, I think that was part of Sanjeev's question. They're all very confident that their regulators are going to approve that enhanced cost related to the cost recovery. So and they're great. They're gaining quickly in popularity as well. So I really think micro PMUs are something that will be very mainstream in the next few years. So.
Yep, I agree with you. Thanks for agreeing.
So maybe you can explain, Mani, the connection between micro PMUs and the protection system. Would the micro PMUs become an input? Those measurements become an input to the protection system. Is that the plan?
Yes, that's a plan. Because the topic of microgrid protection itself is getting complicated. Any help you can get through proper measurements and other support, that's what this whole thing supports that. So as Gary made it clear. And
the use case doesn't have to be deep penetration of DER. A lot of companies still, a lot of client utilities still have really bad AMI, right? Maybe they're getting hourly readings from their AMI, or they're getting daily readings from their AMI. And so getting the input from the micro PMU is a much more refined way to gather data than just simply relying on their AMI. So
yep. I think integrating AMI data with AMI with microgrid, I'm sorry, micro PMUs makes a lot of sense.
Gary, what quite a clarification question. Yeah, I realize that AMI is not a very useful thing today, given the way AMI is constructed in terms of doing anything in real time. But why jump to micro PMU when SCADA is very easily available?
Is this the question? Are you asking me or somebody else?
You can answer, but I was actually reacting to what Gary had said about that because AMI is not available, people are jumping to micro PMUs. I guess I would try SCADA before I would try micro PMU, but maybe there's a reason why you should jump to micro PMU.
I do think that's a fair analysis, Anjan. I do believe that a lot of utilities that don't have deep penetration of cap banks, voltage regulators, other non-substation field devices see the micro PMU as a very flexible device from a location and power quality perspective. And so I do believe SCADA, a robust SCADA capital investment program, is part of most of our clients' capital plan. Yeah. But I think deploying micro PMUs is a very quick way to get to vulnerable feeders and to have better data on their power quality, and especially if they're experiencing DER growth on those particular circuits. So yeah, it's a good point. Yeah.
Yeah, the reason I brought that up, Gary, was because somebody already pointed out that the micro PMU data is difficult to integrate into the ADMS, whereas SCADA is already integrated.
Yeah, I think it's fair. I think that's a fair statement. Yeah. So.
Yeah, I have one very quick comment there. I agree with Professor Bose's observation that we don't have much industrial information on micro PMU integration with ADMS and DERMS. There are a couple of things we are observing. We had at DOE in National Renewable Energy Lab a couple of projects last year where in inverter-rich microgrids, what we could observe was the low frequency oscillations which were not observable with the AMI, we could observe them using micro PMUs. So that's one application where we clearly have some practical data on. There is another thing which I would like to bring about and get some guidance from Professor Mani and Professor Bose is what is happening is AMI is one level of accuracy. Micro PMU is a very low level of total vector error and accuracy, a very high level of accuracy. There is something in between. Most of the practical relays now are having some level of phasor measurement ability. Their total vector errors are higher than micro PMUs, but which optimal total vector error we should choose considering the distribution system measurements and applications. I think that is still from a practical point of view we are trying to analyze. But if somebody has analyzed, we would like to hear from them.
Good point. Good point. I agree with you. My general comment is this is a complex topic. We are learning, so any help you can get from different angles will be very helpful. And by no means this topic is completely resolved. It's going to be more complex and it's going to evolve, into many other untouched territory. That's all I said.
Just to add some comments on total vector error and what application will work. I mean, of course, this is very important, and then there are some IEEE working group now focusing on distribution PMU and looking at total vector error and how it results into different applications that we can use. Of course, in distribution system, it's more noisy and more deformed waveform compared to transmission. But at the same time, especially the PSL one, now there are more distribution PMU, but especially the PSL one does provide at high rate of data, and also, at least they claim it's more accuracy is higher in terms of what they report, because being coming from the power quality community. A lot of time it will depend on CT and PT, but the application itself is not very clear in distribution system, and one is similar to transmission, like health monitoring. That will definitely, micro PMU will definitely help better than SCADA if you're thinking about health monitoring of let's say a solar panel or inverters, especially with that, or even protection and other things.
That's excellent point you made, Anurag, and this whole thing has become such a complex monster. How do we are still learning, and there's a lot of room to learn, and it's interesting. In the last 20 years, things have suddenly took off. Until that time, it was a sleeping animal, the distribution system. So that's all. I'm excited to see that all these developments are taking place, and I'm sure things will continue beyond my lifetime.
So along those lines, Mani, let me ask you this, since I'm not in the protection area. These standards are good, and I presume that what you presented today will become a standard, but they're at a high level for in terms of what the protection engineers have to do, which is to determine what the settings ought to be, where the protection gear has to be put in, and all of those kind of the design of the protection system itself. And it seems to me that what happens is that people develop best practices, like what you said on your slide on what system studies do you need to do to determine your protection system. So the question is, are there best practices appearing now for microgrids? I know that there are already best practices for determining, let's say, protection systems for wind farms. You know, there's several protection companies that kind of specialize in doing that. So are there similar things happening on the microgrid side? Do you know?
They are happening, but people are still learning. And I cannot quote anything specifically here because the subject is so complex, and so we are learning from the past experience and how we can do that. So Anjan, I don't have any real precise answer for your question. That's all I can say. That, and it's still evolving. And you see, in the first place, protection itself has been a complex topic.
Yeah.
And I tell you, to bring all these things, I had the fortunate fortunate incidents to talk to Lou Blackburn, who was a very well-known protection engineer. And he settled down in Seattle area, so I hired him to help teach a graduate course with him. And I asked him this question that, Lou, how did you learn all these things? You know, and then he said, Manny, I just want to let you know that the more you learn, you realize the less you learn. So that really opened my eyes, saying that how to learn. You see, people don't get into the protection area because it is such a complex thing. But now with all this microgrid protection or microgrid evolution, people are now paying more and more attention and then learning. So in the final analysis, we are all going through a learning curve, and we have to come together and learn from each other and see how these things will go. And of course, I'm not touching transmission. It has its own challenges and so on. So I am learning, and I hope it will help me as well as others who are in distribution protection in general and microgrid protection in particular can learn more about all these things. So I don't have any specific way to answer the question. So this is what I think.
Yeah, Manny, if I may, and Anjan, it is a good question because honestly, the microgrids that we're designing are private microgrids for personal industrial convenience, right? Data centers, university laboratories, medical centers. Those are the ones, Department of Defense, right? Those folks can afford microgrids, and so the microgrid market seems to be dominated by commercial industrial entities, not microgrids for the sake of the grid or the system. So utilities really aren't building microgrids per se. What they're doing is allowing commercial industrial folks to connect and have a microgrid. So the market is a little bit unique from this perspective. And of course, there's a lot of pushback on the utility protection guys to make it a least cost solution, right? So to eliminate studies, minimize the cost of studies, reduce the time required for studies. So it is kind of an interesting marketplace right now, and best practices coming out of that type of competitive market may not be indicative of best practices we would use for grid stability or system stability. So it'll be interesting to see if actually two markets develop, those types of markets to protect commercial interests and those type of markets to protect the system. So we'll see. So
that's exactly why I asked that question, Gary, because you know, if you read the technical papers that everybody's writing, every one of them are proposing microgrids to help the grid. So this will be grid forming microgrids or grid following microgrids. And that's not the purpose, like you said, of the private microgrid. They just want to get out of the way if something is happening on the grid. And so we're at cross purposes here.
Yes, definitely. So, and they don't want to pay to protect anyone else, right? So,
right, exactly. And but the purpose of this standard is to try and go there. as to where the microgrids become an integral part of the grid in helping grid stability or grid whatever formation, voltage control, all the rest of this stuff, because that's what we are writing papers about.
And it's interesting. That's usually the Standards Association. Usually the working groups are dominated by those types of people, right? They have a grid level interest, right? And so, I could easily see version 2 of the guide. So Manny, you can't retire just yet, version 2 of the guide, maybe having a little more, be a little more influenced by some of those commercial interests, let's say. So, but once again, they don't want to get involved in stuff like that. They just want their project to be done as cheap as possible. So,
another point I like to add is that the Department of Energy Office of Electricity is committed to this whole microgrid program. That's how they are holding this R&D review every year. And I think the next one is coming soon. And I think I'm sure you will all get email from them. So we're all learning. So that's all I can say that. And I hope we'll advance the state of the art as we proceed along. That's all we can do. And it's not going to be an ending project. 100 years from now, people may still be working on it. Who knows? And as it happened 100 years before. And so it's whatever small contribution each of us can do, that will be great. That's all we can do.
Part of the answer to your question, Anjan, is a recent FOA of Department of Energy, I believe 2745, encouraging consortia between universities, manufacturers, vendors, and utilities to develop case studies and approaches in protecting microgrids with heavy penetration of IBRs. So probably some of these projects will transpire into broader solutions. Not all of them will be for private, relatively isolated autonomous networks.
Well, yeah.
Thank you, Manny, for your presentation. It was encompassing, and you've done a marvelous job of squeezing it into 30 minutes.
Oh, I appreciate it. Thanks. And well, it's not going to be ending since the advent of electricity. We've come a long way since Edison's time and Tesla's time. And I think 125 years later, we'll see still people talking about it, though none of us may be existing at that time.
So since we have Miroslav and Mani both on here, let me sort of put a UI assist type question. I mean, did we learn anything in the projects that you're doing, Miroslav, Mani, on UI assist that would inform this process of developing standards or developing best practices? And I think that would be something to put into the UI assist report.
We are using case studies. Our case studies are mostly limited to simulations.
Yes.
My understanding is that when they reach the hardware in the loop stage, which would be some kind of a sequel to the work that we are trying to complete this year, then we will see much more informed conclusions that we can draw.
Yeah.
Ironically, when you were making your earlier comments about micro PMUs, it occurred to me, since I worked many years ago, more than I am willing to disclose, on the prototype of PMU, one of the first prototypes of PMU, and they have actually emerged from symmetrical component distance relaying. When they were first applied in the digital domain, they were used as a platform from which PMU emanated. Now it seems like PMU is coming back into protection 40 years later.
Yeah. That's a very good comment. So I think we have come a long way, and I think we'll continue to work on it. And I think we should have confidence that this is going to help. So, and keep on working. Each one of us make our own contributions. So the whole process will continue. Each one of us is going whatever we can do. So at least my desire to present this topic is to say that there's what is known as a Standards Association, and they are doing the work, and besides what normally other people do. So this is a learning for experience for all of us, and I'm learning. So I think thank you, and I think anything else, Sanjeev?
Yeah, I think we are good. Thank you, Dr. Mani, for the presentation and interesting discussion we had after the webinar. So I'll conclude this webinar, and thanks once again for everyone for participating and for their time. And
thank you.
Thank you.
All of you,
we look forward to see you again.
Yeah. All of you have a good new year, though it is belated. Take care.
Bye-bye, everybody.
Thank you. Goodbye.